Hello everyone, welcome to YKS Sri Sai. Now, last class we have discussed about the functions. Now, we'll do some problems on this. This will be from exercise 1.2 NCERT textbook, question number 9. The question is, let f be a function from n to n defined by f of n is equal to n plus 1 by 2 if n is odd, n by 2 if n is even, for all n belongs to natural numbers. State whether the function is f is bijective. So, we know from the definition of bijective function, a function is said to be bijective function if it is both 1, 1 and onto. So we'll check one by one. If it fails any one of this, then it will not be a bijective function. First case, we'll check for 1, 1. So let us take, let x1 and x2 be two elements which belongs to natural number. But we know that for a odd and even we will take different numbers. So we'll assume that x1 equal to 1 and x2 equal to 2, as both 1 and 2 are natural numbers. Now we'll do one by one. First, let f of x1 equal to f of x2. Now this when you see separately, you can see f of x1 is 1, therefore we can take f of 1 and we can check for f of 2. Now 1 is an odd number, therefore we'll have to take this function. So it is 1 plus 1 by 2, which is equal to f of 2 is even number, therefore we'll take this function, that is 2 by 2. This is 2 by 2 equal to 2 by 2, that is implies 1 is equal to 1. This is f of x1, that is f of 1 is equal to f of 2, but we can see 1 is not equal to 2. If we want to prove it is 1, 1, for every f of x1 equal to x2, we should get x1 equal to x2. But we have f of 1 equal to f of 2, but 1 is not equal to 2. Therefore, f is not a 1, 1 function. Now comes next to check whether it is onto. But you have to focus on the question. They were asked to find out whether f is bijective. So there is no unnecessarily we have to spend our energy to find whether it's onto or not. In any case, whether f is onto or not, still the function will not be bijective because it is not 1, 1. Since it has failed the first test itself, no need to do other one and then come to conclusion. Any of which result not going to affect us. Therefore, we will conclude hence f is not bijective. Because f is not 1, 1. This is enough justification to say f is not a bijective function. Well, students, now we have completed question number 9. Now we'll go to question number 10. Now the question is, let a is equal to real numbers except 3, b is equal to real numbers except 1. You have to consider a function from a to b defined as f of x equal to x minus 2 by x minus 3. Is f 1, 1 and onto? It's just like indirectly asking whether it's a bijective function. So in this case, we have to compulsorily verify both 1, 1 and onto. Whereas in previous case, when they asked bijective, we have concluded first one when it fails. Okay. Now we'll start with the same property. To call any function as 1, 1, we have to prove that for every x1, x2 belong to a, there should exist f of x1 equal to f of x2. Okay. Now we'll take two elements. Let x1, x2 belongs to a. A is r minus 3, that is real numbers except 3. Now for this every x1, x2 belongs to a, we will take f of x1 is equal to f of x2. Now we will substitute in the place of x1 to the left side, x2 for the right side. Now it is x1 minus 2 by x1 minus 3 is equal to x2 minus 2 by x2 minus 3. Now see, we will cross multiply this one. I will get here this one. We will get x1 x2 minus 3x1 minus 2x2 plus 6. Now I will cross multiply this side, which is equal to x1 x2 minus 2x1 minus 3x2 plus 6. Now you can see on opposite sides, same sign terms, like terms will be cancelling. x1, x2 is plus, here also plus, these two get cancels. Plus 6 get cancels. Now this is minus 3x1, okay, this is minus 3x2. I am going to bring minus 3x2 to the right side, it becomes plus 3x2. Already we have minus 2x2 here. Here we have minus 2x1 related here. This minus 3x1 sent to right side becomes plus 3x1. Now this becomes x2. Here it becomes x1. So for every f of x1 equal to x2, we got x1 to equal to x1. Therefore, the function f is 1, 1. We have proved first part. Now we'll go to the second one. So now you have to verify whether it is onto. For verifying onto, we'll just assume let y is equal to f of x. Now we have to make x as the subject. Therefore, I'll write y is equal to x minus 2 by x minus 3. By cross multiply, I'll get xy minus 3y is equal to x minus 2, or I'll bring both x same side. xy minus x is equal to 3y minus 2. Now take x as common, you will get y minus 1 is equal to 3y minus 2, or x is equal to 3y minus 2 divided by y minus 1. See this here, f of x is the subject, in this case x is the subject. Now to prove onto, we will get, consider some y belonging to B such that there exists some x belonging to A. So we will prove this one. Now we know in this case, this f of x equal to y, that's what we have to prove. We will take f of x, in the place of x, we will substitute this function, which is f of 3y minus 2 divided by y minus 1. Now we know what is f of x we have here. Now in the place of x, we have to substitute the function what we got, that is 3y minus 2 divided by y minus 1. Now when you substitute here, we will get 3y minus 2 divided by y minus 1 minus 2 all divided by 3y minus 2 divided by y minus 1 minus 3. This f of x function what I am substituting here. Now I will simplify this part. You can see here, this is f of x what I have taken. Now I will cross multiply this one, which will take us to 3y minus 2 minus 2y minus 2 minus plus 2 all divided by y minus 1 divided by this one is 3y minus 2 minus 3y, this is plus 3 divided by y minus 1. Now you can see y minus 1 and y minus 1 get cancels. Now you can see this is 3y minus 2y, plus 2 minus 2 get cancels. You will get here 3y minus 2y is y divided by, you can see minus 3y plus 3y get cancels. Minus 2 plus 2 will give you 1, which is equal to y. So what we got finally is f of x equal to y. Therefore f is on 2. Therefore is f 1 1 and on 2? Yes, it is 1 1 on 2. 1 1 and on 2. Therefore it is also a bijective function, but in our question they asked whether it is f is 1 1 2. We have clarified that one. If they ask you it is bijective, yes, it is bijective. Thank you very much. So keep watching my channel and do subscribe my channel, YK Sri Sai.